Just 6601. Welcome to the second workshop for Kakaako Our Kuleana. We wanted to have some of the student facilitators talk about why there's maps and why you're seated facing each other. So I'm going to hand it over to Tamara to explain what we're going to do, and then we'll give probably just a few more minutes to do the interactive activity, and then we'll get started with the presentations. So I'm going to hand it over to Tamara.
Hello, everyone. My name is Tamara. I'm one of the University of Hawaii facilitators this evening. I just wanted to thank you all for coming and being on time. See the folders you have in front of you. If you could please get into groups of 3 or 4 with the people around or across from you. That's why we're sitting in this unique setup. Inside the folder, you will find 2 maps. And for this activity, refer to the map without the blue on it. So without the blue. And in your groups, please answer the following question that we are just getting up right here. So the question is, you have 5 minutes to, can you map some of the infrastructure needs that you see as you live, work, and play in Kakaako? So the question is, can you map some of the infrastructure needs that you see as you live, work, and play in Kakaako? You have 5 minutes to identify these on the map and discuss in your groups. If you have any questions, we've got our UH facilitators walking around to help you guys out.
And just to mention, we'll be collecting these and try to compile them into one giant map that kind of reflects community concerns. Thank you. Shared in the future.
Welcome, everybody. Hello. Happy Tuesday. Woo! Okay, everybody, thank you very, very much. It's great to hear all the discussion going on. We're going to officially get started kicking off of this exercise. The map you see in front of you, right there, you have 2 maps. One map is what Kakaako looks like today. The other map, and which will have another activity around, is what Kakaako may likely look like at the end of the century. What we'd like to do is, okay, sorry. Okay, could we get everyone's attention? Thank you. Okay. Okay, what I'd like to do, boy, this is a great sign when people are so excited and into the exercise and the discussion. What we'd like to do tonight, we have a jam-packed agenda for tonight's Public Academy. I know that Olelo usually likes to say a few words. Is Jonathan here? Oh, no need. Okay, all right. Okay, so on behalf of the Department of Urban and Regional Planning at the University of Hawaii at Manoa, I'd like to welcome all of you to our second workshop as part of the 6th workshop, Public Academy, Kakaako Our Kuleana, a public academy for everyone. We are co-sponsoring this event with the Hawaii chapter of the American Planning Association. I don't know if Kimi Ewan is here again. Kimi is the chapter president here. And we're honored to co-sponsor this event with them. We'd also like to thank the HCDA for allowing us to use these facilities, to Olelo for capturing this, and to our students in the Department of Urban and Regional Planning class whose teaching practicum this is a part of their teaching practicum. So thanks, and our staff at the Department of Urban and Regional Planning also. I'd like to just say a few words of logistical things. We usually go for the straight 2 hours, so if you need to take a break, please don't hesitate to do that anytime your body tells you you need to. Second, if you could just put your cell phones on stun, that would help. And lastly, if you are taking this for AICP credit, please be sure to sign in on the AICP sign-in sheet outside. Today's topic is a very difficult one, as many of you know. Some of you are haunted by the odors in Kakaako if you live or work here or frequent here often. But even if you don't, all of us who live on this island, this chain of islands, face the inevitability of sea level rise and climate change. This is a hard issue to talk about, partly because of the uncertainty. We don't know exactly what it means. But with good science, and we've gotten a lot more of it now, and we have some of our leading scholars in the field here today and on video with us. We know that we do have to plan for it. One of the worst things that could happen, right, is that we make our own future disaster. Most disasters are man-made or human-made because of the places we choose to develop and how we choose to develop. Kakaako is no different from anywhere else in the island in its vulnerability to climate change and sea level rise. What it is, however, is an opportunity to plan for something that we know is going to happen and take advantage of the fact that much of it is still yet to be developed. And if we could kind of feel comfortable, right, with this idea that sea level rise is coming and our children and their children will live with the consequences of what we do today, then hopefully we could have a conversation that doesn't create mass panic, and that we could do something in time. Tonight's agenda begins with, I'd like to also introduce Annie Ko. She's my co-instructor for the class for which the students are doing this practicum.
Actually, one more logistical thing. I know some of you are faced away from the screen. We want to encourage you to turn your chairs so you don't have to crane your neck through the presentations. We had the chairs arranged facing towards each other in order to facilitate some conversations, but we don't want you to get a crick in your neck. So if you need to turn your chair around, please do that. You can face it to the front. And then if you have an empty chair near you, can you raise your hand? Because there are some folks who are looking for seats. So folks in the back of the room who want to take a seat, I see Tamami. I can name people that I know, or should be welcome to take seats. Okay, that's all.
Yeah, please keep your hands up until people kind of get seated. Thank you. So we're really privileged to have as our first speaker someone who is in charge of 9 wastewater treatment plants, over 70 pump stations, and 2,100 miles of gravity sewers. I don't know about you, but I think this job would be much too daunting for me. I think it's one of the most difficult, challenging jobs to be in charge of the sewer system in Hawaii. And I promised Laurie that we would be kind. And what I'd like to do is, as she's speaking, you have stapled to your agenda some slips of white paper. Our students will be roving around the room as you come up with questions. Can you please write them on the slip of paper? And the reason why we want to do this is we'd also like to collect your questions, and if there's an opportunity to answer some of them in written form that we could post online, we'd like to do that because there's no way in a short period of time we're going to get to all your questions. So please give applause of welcome to Lori Kahikina.
Oh, good evening.
Oh, thank you. Oh, thank you. Thank you. I was very hesitant to come tonight. I was actually trying to get one of my deputy directors to come, and he refused. So you're stuck with me. I really, yeah. When she asked me, I'm like, man, this is going to be a Lori E and V bashing kind of evening. I said, I already got beat up quite a bit in the media and odors and Kakaako. Are you kidding me? So, I'm not an expert by no means. I actually, one of my employees is here, a branch head. He's probably more of an expert on this than me. So if I can't answer the question, I'm going to turn to him, Loy Kuo. If I could start real briefly with maybe it's Sewers 101. There's some terminology that I might use, and you know, we're engineers. We tend to just spurt things off, assuming everyone speaks the same lingo. But when I've had to do town hall meetings with the mayor, he said, you know, you say certain things, and I think people, I don't even know what you're talking about. So can you please explain some of the terminology? So when you, in your home, you have your own plumbing. When you wash your dishes, take a bath, and flush the toilet, it goes into your own plumbing system. And then it comes out through a lateral. That's really, usually it's a 4-inch line coming from your home, connects to the city's lateral, which is about a 6-inch line. Then it goes into the street normally. Sometimes it's under people's homes. And it goes through a series of gravity lines. It gets bigger and bigger. And then eventually it gets too low that it can't go gravity flow anymore. So we use a pump station to lift that flow back up to ground level. And then we push it out with a pressurized pipe called a force main. And then a series of up and down, until eventually it gets to a treatment plant where we clean it to a certain level. It's all monitored by the Department of Health. And then once it's cleaned to a certain level, it goes out through a big, huge pipe in an outfall, and it goes out into the ocean, or sometimes into injection wells in central Oahu. So just some terminology so that you folks know what I'm talking about when I say certain things. Okay, this is this blue circle. Oh, that blue circle over there, that is the infamous Ala Moana pump station that I've been getting beat up in the media lately. The Ala Moana pump station, its service is all the way from New Valley to River Street. And all of this sewers, all of this flow comes to the Ala Moana pump station, and it pumps about 45 million gallons per day. It's kind of hard to fathom that. So when we had that major spill, it was about 500,000 gallons. So please understand the magnitude of what we in the wastewater industry deal with. 500,000 gallons versus 45 million gallons per day. So I know I was getting criticized for that, but that's what happened. So Ala Moana pump station takes all of the wastewater from Neo Valley, River Street, and then it actually pumps it under the harbor to Sand Island Treatment Plant. Under Kakaako, that Ala Moana pump station is located on Keawe Street. There's actually 2 pump stations on that same property because of the massive flow that's coming in. Pump station number 1, pump station number 2, and each pump station, I believe, has 4 pumps to keep up with all of that flow that comes in every day. So under Kakaako, there's a series of, it's kind of a bad graph, but I just wanted to show you, it's a web. It's a web of sewer lines where it goes from, like I said, that 6-inch to 8-inch to 12, and it gets bigger and bigger until eventually it gets to the pump station. So odors. What causes the odors in the sewer line? So I know in Kakaako, some of the residents were complaining that, well, there's not enough capacity in those lines, and that's what's causing the odors. It's actually the opposite. The opposite effect happens. So this is the sewer line, the sewer pipe, if you can imagine. So imagine you're looking at in the inside of the pipe. This is the sewer wall. And then on wherever the sewer runs, usually a pipe doesn't run full pipe. Pressurized pipes do, force mains do, but gravity flow, usually about half pipe it flows full of sewage. So wherever that flow is that's touching the sewer line, there's a slime layer that is created over here. And in this slime layer, there's a lot of bacteria. And that is what's causing the odor. In the bacteria, it's reducing the sulfate to sulfides, and then the H2S is emitted into the open air over here in the pipe, and that's what's causing the odor. That's what you folks are normally used to smelling, like the rotten egg smell. When there's debris in the line, so
When you flush a toilet, sometimes there's other debris that gets into the line. There's rocks, sediment. So over here, that actually also promotes the odors because every little particle, now that slime layer is also collecting on the outside of the particles, and that's also where the bacteria is growing. So what we're trying to depict in this picture is, okay, this is again the sewer pipe. The bottom part is full of sewage, wastewater, and this is the air. And depending on the where the air is in the pipe, there's different velocities of that air as it's flowing through, as the sewage is flowing through. When there's enough velocity pulling that sewage through the pipe, there's actually a negative pressure. It's pulling that odor back into the sewer line and drawing it with it. So as the water is going through the pipe, there's enough speed, the odor in the air is coming with it and it's pushing it down the pipe. When there's not enough velocity, which is what's happening in certain parts of Kakaako, the pipe is too large. There's not enough velocity. So if you can imagine a pipe, let's say 69 inches in diameter, and you only have a very low velocity, low flow, it's trickling through that pipe. And so as the odors are being created, it's going to escape the nearest route, which is the nearest manhole. And that's what's happening in Kakaako. When everything gets dumped into a pit, what's happening at Ala Moana pump station, it's called a wet well. All of that flow is coming in gravity, it dumps into the wet well. And of course, now you get all this turbulent flow, odors are created. So that's why right near the pump station, there is a lot of odor because of this effect. This is what we call an inverted siphon. It's basically a gravity line, and it's going up like this. And so it's not gravity anymore, technically, because it's an inverted siphon. But that promotes odors to come out. Because if you look, this white space is the air. There's no place else for the odor to go but up through the manhole. And then the opposite effect comes when the flow comes back up, then it pulls it back in. So what are we trying to do to mitigate the odors? This is actually the division that Loy works in. He's the branch head over there. And that debris that I showed in an earlier slide, these are our, Vector is the brand name, but these are our big sucker trucks. They're cleaning trucks. And this is really the bread and butter of that division. So there's a hose over here. And then they send the equipment, this hose, at the end of the hose, there's a high velocity flow tip. And it actually helps to suck out all of the debris that's in the pipe. And so this helps to, as long as we can keep that debris out of there, it helps to minimize the odors in the sewer lines. Another thing that same division does is they put these carbon manhole inserts. So in manholes that we know that the odors are being emitted, they put the carbon filters in there, and as the air comes out, it goes through this filter before it comes out of the manhole pick hole to help minimize the odors. And the carbon does expire, so after so many months or so, they have to replace it. These are what we call odor scrubbers. So at the Ala Moana pump station, if you remember that previous slide where that flow is dumping into that pit, that wet well, these odor scrubbers are to help before the air comes out of the ground, or as it's coming out of the ground, it goes through the scrubbers and it's clean before it's emitted into the air. So it minimizes the odors at the pump station. What we tried to do, what we did do at the Ala Moana pump station is we hired a consultant to do a fan test. And what we're trying to calculate is if we put, I guess like a vacuum at the pump station, we want to try and vacuum all of the air. Because again, at Kakaako, that flow is coming, and it's coming so slow. And remember now, this flow is coming from New Valley. So as it's old, as the sewage is getting older, it's getting more and more odorous. So what we try to do is, okay, if we do a study, have a vacuum at the pump station, there's really only so much we can reach up the lines. I don't remember what the results were, but I think it's probably less than a mile that we can suck in the odors and then bring it to the pump station and send it through the odor scrubbers. Okay, so this is a model. This is another improvement of what we're trying to do. It's real technical, but I just wanted to show that what we're trying to do is we're putting in flow monitors all around the island. And what it is so that we can have kind of an understanding what the flows are doing throughout the entire island in our pipes. Again, remember, it's an engineering study, it's a model, but it's fairly accurate because we put actual instruments into the sewer lines and then we calibrate our computer model with it. But with that, then we're able to see what the velocities are, what the level of flow is, and where some of the odors might be coming, and how we can improve the system. So I know my topic was supposed to be about odors, but Karen said that you folks will probably be interested in capacity issues in Kakaako. And there was this infamous map that I showed when I did a presentation to council. Some of you have seen it, the infamous map with red lines. So we do have capacity issues, both on the solid side and the liquid side. What I mean by that is when you flush the toilet, right, when you make number 2, they're solids, right? So the solids have to be taken care of at the treatment plant. And if you look at Sand Island treatment plant, there's these big, huge eggs. Well, there's one egg now. We're building the second egg. That egg is to capacity, meaning we can't take much more solids. So like all the buildings that are going up, there's a conditional approval that they connect after 2017, because that's when our second egg will be up and ready to go to handle the excess flow of excess solids. Oh, we can gloss over the map. They don't need to see the red lines. Okay, that's okay. I'll describe it. But on that map, there's some assumptions that I need to share. We only looked at the 24-inch lines because I actually got a phone call recently about a project right here in Kakaako, and they're concerned about an 8-inch line. So we did not look at the lines smaller than 24 inches. We looked at a 5-year storm, and let me try and describe what a 5-year storm is. That's the odds of it happening in 1 year is 20%. So I hope I explained that correctly. And full pipe is considered surcharging of the pipe. So the map is not here then? Okay. That's okay. There's certain lines in the downtown area that there's red lines, and actually, how is E&V going to address those red lines? Okay, you folks, many of you are familiar. We do have a consent decree with EPA and Department of Health. It is mandated that we do certain number of projects, like Lloyd's division. They have to do operational things. They have to clean 500 miles per year, smoke test 19 miles per year. That program is about $5 billion. 2 of our major plants, Sand Island and Honouliuli, have to go full secondary by 2024 and 2035. So when you painfully pay every month to us our sewer bill, that's where all your rates are going. 100% of your sewer fees is going to sewer projects. Not necessarily all consent decree, because we have other projects to do. But understand that E&V's priority is, or city's priority is, the consent decree. We are mandated to meet certain deadlines, certain projects by a deadline. If not, there's fines and penalties. So when the consent decree was being negotiated, capacity was not really the focus. The focus was the spills, to reduce the spills. And I know there's we have the stigma of every time it rains, it spills. That is not true. That is not true, and I wish the media would get their story straight, because it's been raining, right? Since August 24th, it's been pouring rain. Have we spilled? No. But do they do a story on that? No. Okay, so the question is the stormwater in the sewer system? Very good question. I just assumed you folks would know it's 2 completely separate systems. There's a whole network of sewer lines and a whole network of stormwater lines, completely separate. However, stormwater does get into the sewer lines, and it's not supposed to. Some of it is intentional. People connect their downspouts to the sewer lines because they don't want their yard to get puddles. Some of it is unintentional. Maybe they bought the house, they didn't realize it's connected, and sometimes there's just cracks in the line. Some of our lines, we're going to talk about sea level rise. Some of our lines are underwater. If we have cracks in the line, infiltration and inflow is getting in. Infiltration is through the cracks and the pukas in the line. Inflow is, like I talked about, the downspouts. And for that Ala Moana spill, when that happened, there's a lot of inflow that's coming in. Sand Island normally processes about 70 million gallons per day. When we had a heavy rain like that, it jumped up to 210 million gallons per day. So it tripled, and it was almost immediate. It happened starting from 3 o'clock in the morning, and we started spilling at maybe about 7, maybe even earlier, about 5 o'clock in the morning. It was fast. So something is connected really close to us for that to happen. It's not coming all the way from Neil Valley, trickling, and coming. Something is connected real close to us with that much of inflow coming in. But it is supposed to be completely separate. And how we're trying to improve that is we do rehab our lines. We call cured in place lining. It's an impregnated resin sock where it's like a pipe in a pipe. So that's how we're trying to seal all of the cracks in our pipes. So we are trying to address that extra inflow coming in from the stormwater, which shouldn't be coming in. Okay, so I covered this. The consent decree is our priority. There's only a certain number of projects in the consent decree that address capacity, and the reason they were in there is because there was a spill. So again, the consent decree focuses on the spills, and our spills have been coming down. We are actually, believe it or not, one of the top in the nation. The EPA has, their goal is try to get 1 spill per 100 miles, and we're very close to that. Some ways of how we can integrate the consent decree, what we need to accomplish in the consent decree is if we know in advance that there's a project that we need to upsize the pipe, we can kind of coordinate it. Why? You must be asking, why don't we just upsize the pipe and make it huge already? So I kind of touched on it a little bit. If the pipe is too large and there's not enough flow, it generates the odors. And with the odors, that H2S is extremely corrosive, and it starts to eat at the pipe. So if we have plastic pipe, it's okay. It doesn't deteriorate as fast. But the other pipes, concrete, it eats it up really quickly. And then now we're going to have a breakage in the pipe. Some consent decree project, I'm not sure. It didn't look like it on my side, but there's 2 projects already in the consent decree that's going to get rid of some of the red lines that on that map, and one is the Ava Street Pump Station, and I think the other one is in Waimalu. Other ways we can integrate the consent decree and capacity issues, if there's cost savings on the existing projects, which is not very realistic. I'm finding in the construction time now, our costs are actually coming in higher than our estimates. But if we did have any cost savings, we could apply it to future capacity projects. Some relief lines are required along the rail route. So rail is doing their own environmental and planning studies. So we can definitely use some of that information. I spoke about this second egg, the second digester at Sand Island. So by 2017, that should be complete. I should say 2016, the second egg is going to be built. We have to take the first egg down, make sure it's in good condition, rehab it, and then by 2017, both will be up and running. And then we do have funds for in fiscal year 14 for planning for capacity projects. Karen also had some questions. So, sorry, no time for questions.
You can ask these.
No, if they have questions, it's okay.
Yeah. So we're on a tight timeline because our next speaker is leaving for Houston tonight. So we're going to spare Lori from the hot seat. But as I said, please, and if you wouldn't mind answering questions written, then we'll collect the questions, give them to Lori, and then post the answers on the website, and then email you, all of you, the website address. How does that sound? Good. Okay. We're going to start our next introduction to our next 2 speakers with a very short video about climate change and sea level rise, done by Kelsey Matsu, one of our students.
Our modeling shows that Kakaako is vulnerable to what's known as groundwater inundation. This means that the water table will rise up and break through the land surface as sea level rises. Sea level is rising as a result of climate change, global warming. And what a lot of people don't realize is that the groundwater underneath our coastal lands goes up and down with the tides, which means that it's intimately, directly connected to the ocean. So as the ocean rises from climate change, the groundwater, the water table, will literally go up. And our modeling shows that right now, the water table in in many areas in Kakaako is could be as close as 1 foot or 1.5 feet to the ground surface. Between the water table and the land surface, there's an empty accommodation space made up of soil and whatever else is buried between the land surface and the water table. When it rains, that accommodation space fills up with water very quickly, and once it becomes fully saturated, the water has no place to go except down through the storm drains, which drain into the ocean. At high tide, the ocean floods up into the storm drains, and as sea level rises, the ocean will flood up into the storm drains even when it's not high tide. So at first, you're going to see severe flooding taking place when there's prolonged rain at high tide. And we've seen that on a couple of occasions already in the past few years and in the past few months, actually. Soon, you'll see severe flooding during any part of the tide cycle when there's heavy rain. Then you'll see severe flooding when there's no rain and it's just high tide. It's ocean flooding, it's ocean water coming into the streets.
Whenever there's a hard rain, we used to call it Lake Kona because it was Kona Street. And it would flood so bad that the body shop across the street actually moved their paint booth about 20 or 30 feet further inside the building to get away from the waves that were created when some guy in a big pickup goes flying through there, you know. We ended up with rocks in our driveway and everything just from that amount of water. But Queen Street floods all along there too. So.
In a nutshell, you have a drainage problem that's developing, and simply building individual towers without also taking into account the buried infrastructure, the drainage system, and the other land uses that are around the towers is neglecting, I think, an important aspect of how Kakaako needs to be envisioned moving into the future.
It might be nice in 20 years. You know, if all the plans go through, it could be nice. I just don't see how the infrastructure is at all ready to support it. It's way behind. As far as even the utilities, they're constantly utility crews here at night. Our sewer system's already taxed to the max, and 20 new high-rises. I just don't see how it's going to be supported by our present sewer system. We're having problems with this building with our sewer overflowing already.
The towers themselves might not be vulnerable to flooding, but the roads to and from the towers and the neighboring properties, they all need to be considered as the sum total of the entire Kakaako region.
Thank you. So there was one misperception, right, that the sewer infrastructure is inadequate, but as we learned from Laurie today, that's not the problem. It's that there's not enough flow. But there are other types of infrastructure, and today we have the privilege of hearing from Danielle Spirandelli. She is a professor in urban and regional planning and a beloved colleague. And her specialization is sustainability planning and infrastructure. So remember, sewer is one of many different parts of our infrastructure. And to give us kind of an overview and an idea of what the climate change means for all the various types of infrastructure, please welcome Danielle Spirandelli.
Hello, good evening, everyone. I'm going to grab this. So It's my immense pleasure to be here with you all tonight. And thank you, Lori. That was an excellent presentation, and I learned a lot from you, so thank you. So tonight, I want to talk to you a little bit about climate change. I'm going to talk a little bit about what we might expect in terms of the impacts. I won't be able to talk about everything and all of the related impacts that we will expect here in Hawaii, which are pretty vast. There is a very good report where there was a few handed out. Do you mind if I? By UHC grant. So if you want to learn more to understand all of the various types of impacts that we can expect in Hawaii, I will actually be showing a link to this report. You can get that. But for today, I'm going to talk about more simply about what we know in terms of the science and what some of the implications might be for Kakaako. Once we get this going. Oh, I know those woes too well. But I can start talking a little bit in terms of what we know in terms of the carbon dioxide that has been and continues to be emitted into the atmosphere. We know from our observations here in Hawaii on Mauna Loa that carbon dioxide and the emissions in the atmosphere continues to rise. And I think just pretty recently, this last year or so, we went beyond the 400 parts per million, which for climate scientists is quite alarming. But what I want you to all keep in mind when it comes to carbon dioxide and the type of emissions in the atmosphere is that even if we were to stop emitting today and froze everything, the amount of time it would take for our planet to reabsorb the carbon in the land, in the vegetation, in the trees, and especially in the oceans would take on the order of hundreds of years, probably longer. We don't know exactly how long, but certainly long enough for our children and most definitely our children's children to be feeling the impacts. So that's why people and climate scientists and landscape architects and planners are pushing this idea that we really need to be planning for the future. And not just the next 20 or 30 years, but really the next 50 to 100 years. So we need to really be thinking about what are our cities and what are our neighborhoods going to be looking like, and how are we going to build them, and what will the implications be in 50 to 100 years. Okay, we're close. Okay. So, there we go. Okay. Okay, so this is the observations of CO2 in the atmosphere. They continue to increase over time. We can see that, and that's continuing to increase with the emissions that we emit. This is the report that I referred to. It's a summary report that you can look at on your own time, and it talks about all of the various impacts that we can probably expect to see, and the effects both to our communities but also to our ecosystems here in Hawaii. And one thing I would like you to also keep in mind is that the science is still evolving. There are a lot of very talented climate scientists here in Hawaii and elsewhere that are working very, very hard to understand and to be able to predict what will happen in the future. But modeling and being able to model with certainty is very, very tricky and very, very challenging, which is why sometimes we can get contradictory or conflicting information. But the that's what science is about. It evolves, it improves, and we learn more. So this is just sort of a summary slide that shows the various different kinds of impacts that we can expect climate change to have on Hawaii. We can expect various different impacts on the air temperature. We do expect it to increase over time by 2100, somewhere between 2.5 to 4.8 degrees Fahrenheit. We can also expect changing precipitation and rainfall patterns, both increasing and decreasing. And that sounds a little weird. Why would it both increase and decrease? Well, we actually, as we all know, live in a place where we have quite dynamic microclimates. We have these things called the trade winds, which can keep us cool when we really want them. Well, there's a little bit of uncertainty of exactly what will happen in the future with those, but also in some places we're going to probably have warmer and wetter, in some places drier and hotter. And then we can also expect an increase in sea level rise. And again, I'm going to talk a little bit more detail in terms of what we might see and some of the different models that tell us what kinds of predictions. But generally, what people have, and certainly scientists have started to talk about of what we should start planning around is somewhere between 3 to 4 feet of sea level rise by the end of the century. So there are many other impacts. I'm not going to touch on all of them, but I do want you to be aware that there are other impacts in terms of ocean acidification, et cetera, that will be affecting our habitats and our ecosystems. So the Hawaii temperature. So this slide shows it shows past trends, and in terms of changes in temperatures that's being observed certainly over the last 30 years or so. And generally what we can expect is that overall, over the last 30 years, we've seen a change of somewhere on the order of about 1 degree. 1 degree change in Fahrenheit over the last 30 years. There is a difference in terms of whether you're at the lower elevations versus the higher elevations. So we're seeing a greater change in temperature at higher elevations versus lower elevations, which actually has a huge impact in terms of our forests and habitat and places where other species live up in the upper elevations. But you might look at this number and be like, okay, 1 degree over the last 30 years, that's not too bad. We can adapt to that. The thing is, if we overlay that onto our urban environment, we can actually expect quite a difference in terms of temperature changes where we're the most dense, where we have the most concrete. And this has to do with what many sort of scientists have been researching around the world, that cities have something called the urban heat island effect. In our urban areas, there's somewhere on the order of maybe 5 to 7 degrees higher temperatures, warmer. And you can feel that, right? When you're downtown urban Honolulu, it always feels hotter than when you're out in the rural or agricultural. So you overlay that with increased temperatures over time, and people are starting to be worried about the implications in terms of, especially when we start experiencing those really hot spells. You know, so that 1 degree is maybe just an average, but we always have, you know, it's really hot, what, in August, September, October, we're all sweltering, right? So it can really affect people that are more vulnerable and people that might be impacted by things like heat stress in the urban environment. Precipitation trends, we've been seeing a trend overall across all of the islands. Rainfall has been going down. Pretty much It's pretty much a pattern that we see across all of the islands. Now, what will happen in the future is a lot more uncertain. We have a lot more certainty in terms of temperature increases, but when it comes to rainfall patterns and what we might expect, it's a lot harder to say, even despite our observations of the past. For the future, it's much more difficult to predict. But what we are seeing is some more extreme patterns. So we are seeing more drying in drier places, and then it's getting wetter on the wetter side. So basically the windward side versus the leeward side. And so this image shows a map of the probability of areas along these islands of experiencing more drought, particularly in the wintertime. And you can see a trend here, right? A pattern where all of the leeward side of the islands are probably going to be expecting to experience drought. Along the lines with more droughts, we can also expect these larger, flashier storm events. We had them pretty recently, right, where it's just sudden huge storms. And those will most probably be followed by periods of drought. So we're going to be experiencing these extremes from one end to the end. I'm going to talk a little bit about sea level rise. What's interesting about sea level estimates is that you can see various different estimates anywhere from 1.5 feet to all the way up to 6 feet. Now, why is this? This graph shows various ranges. It's actually in meters, but you can multiply by 3 generally, and it gives you feet. And it gives ranges of what we might expect by 2100 for sea level rise. And you can see some very big ranges. The reason why this is because some modelers actually incorporate the possibility of the polar ice caps melting and having sort of a devastating sort of melting, which would have a huge effect around the globe, especially in all coastal areas. But generally, most people would agree that sticking to somewhere around the 3 foot, somewhere between the 3 foot to 4 foot, is pretty much the minimum that you can expect for the future. So what do we expect in terms of the impacts of that? Well, we certainly expect to experience more of these sorts of conditions along our beaches. We expect to have our homes and whatever infrastructure along the coastline to be impacted by storm surges and a combination of sea level rise and storms and large waves. And we also expect what Chip Fletcher was explaining, more inundation of groundwater seeping up from our storm sewers. He explained really wonderfully in that film why that is. And it has to do with our geology here in Hawaii. In the coastal area, we have this thing called this cap rock here, which is where our groundwater or our fresh water lays. And anywhere from, if you have a large rainfall event that can further saturate that space, and then you add the possibility of sea level rise. And so this blue line right here, that shows where the bottom end, and this is a very stylized, simple version. This is our geology is much more complicated than this in actual fact. But just to give you an idea of why we would have this water coming up inland before the sea is actually coming over top the coastline. It's because the sea level will be pushing underneath and pushing the fresh water up inland. So this is a map that shows from some of the models from Chip Fletcher's Coastal Geology Research Group, some of the things that we might expect to see in the future. So the green colors and the blue, the light blue colors, perhaps you can see, hopefully, show what we might see with 3 feet of sea level rise. And you can see how there might be some ponding all the way inland before we see any impact on the coastline. And what Chip really emphasizes when you see him speak is that the critical elevation is going to be somewhere between 3 and 4 feet. And what they're finding as they refine their models is that as soon as we get over that threshold of 3 feet, you're seeing tremendous amount of flooding all through urban Honolulu, all through Waikiki, Ala Moana, and up into Kakaako. Oh, this is an old version. This is a great movie, which I will not show right now, but we'll put on the website, and I highly suggest you take a look. It's this great 3D visualization that shows you the different buildings that will be impacted. That's estimated. In Hawaii, in urban Honolulu, in Waikiki, and then Kakaako is sort of on the side. But you can look at that on your own time. These are just some images that are probably fairly familiar to you. This is an image here that was taken, this was at Fort DeRusi, and this was during high tide, only high tide. And if this was a movie, you would hear the waves flapping and the water just coming up right through the storm sewers. And this is high tide at August this year. This is Mapunapuna. So you're all probably you might have had to drive through one of these. And this is, again, high tide. There was no huge storm event. There was no huge rainfall. It was just high tide that pushed up. And this is mostly salt water, marine water. These are images from the August rains. This was from just close to Queen Street. And I imagine you're all probably more familiar with this experience than I am. That's Alakea, yes. Yeah. And then this is an image of a local carpet business in Kakaako that has had flooding. So Lori did an excellent was really great talking about the difference in our infrastructure between having a combined system versus a separated system. And this is kind of what it looks like a little bit underground, where you've got one pipe for all of the water that flows off of the streets and off of parks and different places and goes into our storm drains, and that goes into the stormwater system. And that's separated from the sanitary sewer pipe, which is what is connected to the laterals that Lori mentioned, which is connected to your sinks and your toilets, and et cetera, in your house. Now, the problem that Lori was mentioning is that we have these things called inflow and infiltration, which is kind of a technical term. You don't really have to remember any of that. But the basic idea is that we have sort of these cracks in this, sometimes these poorly connected systems or pipes or connections between the two systems. And as a result, if you can imagine, these pipes are getting submerged in water more and more, either from sea level rise or high tide, or because we're getting a tremendous amount of rain, or both at the same time, which can happen, then you could see how water would seep into the stormwater system, overwhelm it, and that's probably why you'll see this kind of thing in the street. And sometimes the water gets connected, it's so saturated underneath that the water then is, they're not separated anymore. They're virtually connected because the water is coming in and out because there are cracks and they're combining. So it's either the water and the sewer and the waste is combining. So that can happen as well. One of the other major impacts from having sea level rise and salt water and high tide is corrosion. So that can, over the long term, be a real pain in the butt for your department, I'm sure. And you can also have major infrastructure damage from roads, etc. So I only have 2 more slides, but I did want to mention this. We're not alone in these challenges in the United States. Many coastal areas across the world are having to deal with and come up with very creative ideas of how to think about our infrastructure in different ways. Now, Miami has come up with their own ideas. They have to pump their storm water out of the system and send it upland to get it out because the high tide has come up too high. It won't go out to the ocean. They've just started installing 70 to 80 new pump stations, which is costing them about $200 million. And that's just to deal with the problem today. And they've got to deal with sea level rise on top of that in the future. And I want to just end with this. I think that it can feel very overwhelming about what to do and how to approach these challenges. But there are examples, and I know that Judith is going to give some fantastic examples of how we are going to need to adapt and think about our infrastructure and our urban environments in a different way. This is one way I'd like people to begin to think about it in terms of designed experiments. And the reason why is because we don't know exactly how things are going to be in the future. But if we can start to approach things as experiments where we're going to try things out in a collaborative way by partnering up with other agencies, with other groups, with communities, with the city, with the university, with designers, with the planners, and we start to test out different types of ideas, and that's what was done here in the Bridgeport Coastal Bioretention Project. They're testing out an idea, and they're going to monitor it over time to see, oh, how is this going to work in the long run? And I'll end with that. Mahalo, thank you.
Thank you, Danielle, for an excellent Infrastructure and Climate Change 101. If you notice on the back of your agenda, our students have prepared a nice fact sheet. And if you notice at the bottom right corner of the fact sheet, there are different adaptation strategies. Everything from retreat from the shoreline to harden the shoreline, and then many things in between. One of the options is really an option that Judith Stilgenbauer is a kind of a pioneer leading figure in, and we're happy that she came to the University of Hawaii at Manoa as professor of architecture in the School of Architecture. So please welcome Judith Stilgenbauer, and then after that, we're going to do an activity that's been planned by the students. So, thank you.
Oh, that was loud. It wasn't me. Yeah, and my ears are ringing. Well, good evening, everyone. Thank you, Karen, and the Urban Planning Department, and also APA for the kind invitation, and you all for coming tonight. I'm going to spend my 15 minutes, which I'm starting now, on presenting to you some ideas that all have to do with the importance of reintroducing more performative open spaces and green infrastructure back into our cities. So some of what I'm going to start out with was already mentioned. So our cities, as you know, we deal with pollution, issues of air, water, and soils. We see how that pollution affects the water cycle, how much of that pollution has its origin in our cities. We see a lot of engineered sewers and streams in our North American cities. Large amounts of impervious dark surfaces, which contribute to what Danielle mentioned, the urban heat island effect, but also large amounts of urban runoff that is polluted with oils, bacteria, viruses, heavy metals, all kinds of pollutants. So not only have we increased the runoff volume significantly, we're also dealing with a lot of pollutants in that stormwater that runs off these impervious surfaces. In addition to that, and Danielle has mentioned this, we've seen a tremendous increase in carbon dioxide emissions resulting in increased global temperatures that we're already measuring that will continue to rise, and that as one consequence will in turn result in significant sea level changes, approximately 4 feet by 2100 or more. I mean, I personally think that's a pretty conservative estimate from what we see lately, but definitely 4 feet. That sea level rise will affect heavily low-lying areas in many developing parts of the world, and of course also here the island of Oahu. Before I came to Hawaii, I taught at UC Berkeley for 9 years, and in my own research, I'm trained as a landscape architect and work with students. We've looked how landscape architecture and open spaces can help us address some of these issues. And so landscape urbanism, ecological urbanism, a little hard to see in the slide, but urban design concepts that reintroduce more green infrastructure into our cities can help us solve some of these environmental problems I just mentioned. There are a lot of cities in North America, such as Portland, that already have very progressive policies in place. Portland, for example, with its green infrastructure, green streets initiative. Chicago is a city. Many other cities mandate green roofs for new developments, green facades. All of those spaces begin to perform. They provide what we call ecosystem services. Photosynthesis, for example, captures carbon dioxide and results in the release of oxygen that we all breathe, but in that process it also produces biomass that we could use to build things, that we can eat, that we can, generate energy with. We also talk more and more about habitat, the importance of biodiversity in our cities, functioning ecosystems, and so forth. Phytoremediation, bioremediation applications that help us clean up pollution of water and soil and air, or in many other places of the world, such as in Central Europe, already mandated. You can't develop without dealing with your own rainwater on your site, without having green roofs, without dealing in many instances actually with your own waste, both solids and liquids within the development. And why aren't we thinking in that direction in Hawaii, where we have limited resources? And I argue that landscape architecture and ecological urban design can help us go in that direction. One other aspect of my work over the last 10 years has a lot to do with this question of process over time. Why do we think of a development such as Kakaako as a master plan, and we're building these towers all at the same time? Why don't we acknowledge that it's more of a process, that maybe we need to think about it in a more organic, more phased approach? Can we perhaps conceive of urban infrastructure spaces, leftover spaces such as under the rail that will be coming in, or under freeways, as spaces that could begin to perform, that could become wetlands, flood retention measures, and at the same time accommodate human activity, pedestrians, bicycles? Can we get away from this more car-centric, hard solution approach? Another idea, and I'm just throwing out a lot of ideas tonight that we hopefully can discuss when I'm done presenting, would it be an option for the South Shore of Oahu and Kakaako to reintroduce more productive landscape elements into those parks and other underutilized public spaces? Can we look at the shoreline as something that can be an asset, a place for people, but also a place where we could produce food, vegetables, or energy? Are those things compatible? Do they have to be, a contradiction? I don't believe they are. There are many examples around the world, and I'm using student work that I've done with graduate students here at UC Berkeley to illustrate some of these points. This is a park, a derelict, like waterfront site that could become a sort of urban agriculture project, arm the shoreline, treat the water, and at the same time become a cultural and open space facility. And why, can't we think about, say, Kakaako Makai in those terms? I think there's no reason why we shouldn't. Now, we're an island state. You all know that a lot better than I do. We have these very steep and short watersheds on Oahu, and if you overlay a slope map with a Ahupua'a map, you will see that we have a tremendous amount of very flat, very low-lying areas that fall right in that 0 to, say, 10-foot elevation. Furthermore, and I have a lot more slides, but I had to cut it down to 15 minutes today, otherwise I would have illustrated this a lot more elaborately, but what you see here basically is the natural shoreline where it used to be. Over here toward Waikiki, we used to have a lot of wetlands, and you can see how over the course of the 20th century, basically, we built out into the water. So this is Kakaako Makai, Ala Moana Beach Park, Magic Island, Waikiki Yacht Harbor, and you can see how far we've built out into what used to be the ocean, basically. And then these large, low-lying areas here were not only wetlands, they were like salt ponds, agricultural fields, and so forth. So inundation flooding wasn't that big of an issue. Now, our colleagues in Sea Grant produced these multi-hazard inundation maps. So what you see here, the blue is 1 meter sea level rise at mean higher water. The yellow on top of that 1 meter sea level rise would be a storm surge, a tsunami, and the red on top of the 1 meter sea level rise would be a hurricane inundation. And it's quite shocking, actually, when you look at this, how much of that south shore of Oahu will be affected in 100 years, or even in a storm event much sooner than that. How much of our critical infrastructure, the airport, our sewer facilities, energy facilities will be affected. And I personally believe that many of the development plans that we're currently seeing for Kakaako and other places do not sufficiently recognize these vulnerabilities that we all have talked about. In fact, I don't need to go over the vulnerabilities any longer because Danielle already did. But it's basically saltwater inundation, erosion, salt intrusion that will affect our potable water sources. Habitats will shift. We will see huge problems with stormwater management, groundwater inundation. There are a lot of contaminants potentially in the soil, in all that fill material, those man-made soils that we created building out into the water. So there's a risk these contaminants would be released. Of course, a huge topic tonight, urban infrastructure, not only the sewers, also electrical, freshwater, transportation systems, and so forth. In addition to that, there's a social component, right? A public health aspect, there's an equity aspect, who can afford to move away, who can afford to still live in these areas, and so forth. So from here on forward, I'm going to just show you some examples of how my students at UH Manoa in the School of Architecture, under my direction, have, through their creative work, addressed some of those problems. A couple of years ago, we looked at the Alawai watershed and how the Waikiki Alawai golf course, for example, could be put to work. Like, how could we convert it into a more functioning, performative wetland? This is, I think, these are still images from the video that Danielle referred to, where you can see everything that's marked in color, will be heavily affected by a 4-foot increase in sea levels. This map, also a SOEST map, shows what this Alawai watershed, the lower part, would look like in the event of a 100-year storm. And you can see dramatically all the way up to H1, much of Waikiki, the golf course area, much of these lower-lying areas of town will be affected. Now, what we see happening at the moment is that the Army Corps of Engineers and others, and I'm not pointing fingers, but they're proposing hard solutions, walls, and those solutions we've seen in other parts of the world, they tend to fail eventually, right? Look at the Netherlands, look at New Orleans, levees break, walls break. So in my mind, it's not really a sustainable solution in the long run. So my student, Megan, wrote in here in her doctoral dissertation, looked at how some of the problems around the Alawai Canal related to flooding and also pollution could be addressed with more soft, green urban infrastructure. So you can see here in these images, if they keep moving, yeah, here we go, how perhaps we could think of a green infrastructure plan for all of Waikiki that addresses some of that non-point source pollution before it enters the Alawai, how perhaps we can begin to soften the mauka edges of the canal, create more functional, performative wetlands that mitigate flood and so forth. So the argument here is that instead of building walls, we should reintroduce more performative infrastructure that provides ecosystem services. And at the same time could become an open space amenity that people can interact with. So much of that has to do with how we design edge conditions, how we allow people to access these open spaces that could treat stormwater, could treat potentially even, spills, and address some of the flooding and inundation risks. Could we think of a solution where the mouth of the Palolo-Manoa drainage canal becomes a wetland, filters some of that sediment and the pollution before it enters the Alawai? So those are just some examples of techniques that could also be applied, I believe, in Kakaako. Subsequently, in an urban design studio with graduate students at UH Manoa, we looked a little further over at Ala Moana and the beginnings, at least, of the Kakaako waterfront, and we investigated how these vulnerabilities were addressed in other parts of the country, right? Around the Gulf of Mexico after Hurricane Katrina, and then more recently in New York City and New Jersey after Superstorm Sandy. A lot of initiatives resulted in very innovative design solutions. And the federal government is actually putting a lot of money into these initiatives, such as Rebuild by Design and so forth. So we can learn from these design and planning competitions that often resulted in pretty rapid policy changes, actually. Surprisingly, in New York and New Jersey, things shifted really, really rapidly after a disaster had occurred. So what can we learn from that? And there's seriously like a movement that goes much more in the direction of living shorelines and soft defense systems rather than hard defense systems, walls, levees, and so forth. We also see a whole set of accommodation strategies, for example, elevating development, floating development, floodable development, and often a combination thereof. Then the most drastic approach to this would, of course, be retreat or an organized withdrawal from these shorelines. Now, when you look at this Ala Moana and then over here, Kakaako area, what it would look like, the rail coming in, about 3-foot sea level rise, dramatic changes to what this part of town will look like. Now, my student Ronald Ribao in this proposal, and I'm just showing you very few images of this, is questioning this heavy reliance of vehicular traffic on the island. Could we conceive of a model where we use more water-based forms of transportation, such as cities like Vancouver, for example, have with water taxis, ferries? Could we think of a system of canals running through this, low-lying area? Could we reinsert more performative open spaces? Can we focus more on these edges? Can we design them for people so they become open space amenities? Can we possibly think of sort of elevated pieces of infrastructure that facilitate transportation, but that could also become the conduits for fresh water and electricity? Can we conceive of these developments as more closed-loop systems that perhaps deal with their own sewage, their own gray water, their own recycling? Can we integrate urban agriculture components rather than just seeing these things as towers that are completely reliant on the conventional gray infrastructure? Or here another example, Tyler Francisco, looking at layered shoreline defense systems. That's a combination of parks and other open space amenities, very much inspired by Kate Orff's work along the New Jersey shore, oyster texture. How can we look at this shoreline as a more protective sort of green space rather than something we build out to the last inch? And then some people, of course, argue, well, maybe we shouldn't develop at all in a place such as Kakaako. And I apologize, these slides, they don't read very well in the slide. But can we conceive of retrofitting some of these developments, raising critical infrastructure off the ground, allowing buried infrastructure, parking to flood? Can we, again, look at more natural solutions, allow the water in, elevating infrastructure off the ground rather than trying to keep the water out? And I'm going to end with some provocative renderings of, for example, the Waikiki Yacht Harbor. What it looks like today, well, could it perhaps in the future become more of a performative softscape, a wetland that provides biodiversity, ecosystem services, and so forth? Can we conceive of some of these residential blocks that are already existing right between basically Ala Moana and Kakaako? I'm not sure what exactly this would probably be Ala Moana still. Can we introduce more performative green into these spaces, allow the water in, maybe have, instead of looking at PE and a surface parking lot, just vehicular traffic? Can we perhaps think about this becoming a canal, allowing the water in, providing for flooding in a more controlled way, and also, again, providing a place for wildlife, biodiversity in the city, and so forth? Ala Moana Boulevard, well, not really that great a place for people at the moment, right? So could we conceive of that as a really beautiful waterfront promenade along the entire South Shore? And then as sea levels rise, perhaps we can elevate critical infrastructure off the ground, allow the water in, and then in 30 years, 50 years, well, maybe it becomes a wetland. The shoreline will be where it used to be again. And, eventually maybe even that infrastructure has to move further. Mocha, I hope no one lives in this low-lying area. But, this is sort of the visionary thinking students come up with, and we encourage them to come up with, because I think this is the boldness of the thoughts that we should be developing, rather than looking at individual towers, rather than looking at individual sewer lines. And I don't mean that as a, I think it's important for us to keep the bigger picture in mind. And so rather than doing what they did on the Eastern Shore, where we were rebuilding by design after a hurricane hit, these are 3 hurricanes that came really close to the island about a month ago. If one of these things had hit, we would have probably had a similar situation to New York after Superstorm Sandy. Can we perhaps on Oahu, rather than rebuilding by design, sort of anticipate by design? And I think Kakaako, there's huge potential to actually do that. And I was really excited that about a week ago, the Obama administration, the White House, actually released this illegible in the projection, unfortunately, memo that went to all federal agencies and mandated, well, it can't mandate, but it recommends that the federal agencies apply green infrastructure measures to all of their projects. And this memorandum that came from the Obama administration stresses the importance of ecosystem services. And it's really, for someone like me who works in this field, it's quite remarkable that federal agencies such as the Army Corps of Engineers now are advised to actually use green infrastructure in their projects. So could the state and the city and county and HCDA conceive of a more comprehensive, forward-looking green infrastructure plan for Kakaako? I think they should. Can we think of better, more forward-looking design guidelines, more ecological management practices? Can we somehow redefine our regulatory frameworks to reflect those principles and values? I think that's what we actually need and should be doing in Kakaako. Thanks.
Thank you very much, Judith and Danielle and Lori. One of the things that that's really exciting about working at the university is that we could play with these wild ideas, and we could even touch sacred cows like the Ala Moana golf course, which my uncle would be turning in his grave if he heard this, that it could be turned into a wetland. And some of you have, I could tell by your smiles, also uncles who may have that same reaction. But I think if you look 100 years ago, who would have thought then, who would have envisioned then what we see today? So I think we're all visionaries. And one of the things that we'd like to do, because we cannot assign homework, our students organized a in-class exercise for our academy today. And I'd like to call up Shannon, Tamara, and Kylie to lead us in this exercise. And for this exercise, we want you to tap your imagination. And what we've prepared are in your folders. There's a map of Kakaako with 4-meter inundation. And what we'd like you to do is do as 4 feet. 4 feet, yeah. You guys get a chance to be Danielle and Judith's students for the next 20 minutes or so and do your own imagining. So let me hand this over now to Kylie.
All right, so we wanted to ask you a couple questions for y'all to answer in your small groups. So one of them is, what concerns or challenges do you see in the future for Kakaako, especially with climate change? And then maybe what ideas you can see coming from these challenges, especially with Judith's enlightening display. So if you have any questions, we will all be kind of walking around the room, so feel free to imagine.
And just to add, if you guys have any questions, if you can just put them up like this, and one of our UH facilitators are going to come and take them from you. So if you have any questions, once again, just put them right up, and then one of our facilitators are going to come and take them, okay? Thank you. Hi, everyone. Sorry to interrupt. But it sounds like we're getting some really good ideas out there. There's a lot of conversation going on. And I just wanted to know if anybody wanted to share some of their ideas. Anybody want to share some of your ideas, what you've been talking about with your group? Anyone? I just need one hand up. Just one hand. Oh, thank you. Okay. There you go. You can say your name.
Oh. We didn't exactly draw it in because it's quite obvious from the map. My name's Leilani, by the way. But we propose putting a canal along Alamoana Boulevard because it's all going to be flooded anyway, and then putting in some type of edging to make sure that it doesn't further inundate inland from Alamoana Boulevard.
Thank you, guys. Any other proposals, ideas? Anyone wants to share? Yeah, over there. Awesome. Thank you. Sorry, let me just get over there. Okay, just say your name.
I'm Andrew. I am a junior at Leisure Den Academy. I just came here because I'm pretty interested in this stuff. But one of our group ideas was for the buildings that are in the inundation zones currently on Alamoana Boulevard, is to allow the water to claim where their current lobbies are and create sky lobbies, which are on the second floor or third floor, and just create ramps up to that. So, yeah.
Thank you. That's a great idea. Anybody else? Oh, yeah, over here. I'm making my way over here.
My name's Brian. We thought that there was a lot to learn from New Jersey, Florida, New York after Sandy. They had a 4-foot or 6-foot or 8-foot inundation like on the map, and they've proposed to do a lot of things like moving essential electrical and other things up, a number of feet. So we think that Hawaii should send delegations to learn what they've been doing in those places, which means elevating things like he said. This, of course, is not the 100-year solution, but we think there's a lot of learning in other states that we need to know more about, and it was hinted at today, but there's a lot more to learn. Thank you.
Thank you. We've got some great ideas coming out. Oh, we have another mic over there. Go ahead.
Okay, 2 points. One of the members of the group suggested that maybe we can have some sort of, localized systems. Like if there are high-rises, every high-rise must have some sort of system that would take care of their own sewage and their own whatever usage for that building. But one point that I wanted to point to is that the last speaker who spoke, I'm sorry, I forgot your name. And Miss Judith. I think she had the best ideas of all of us. I think we have lost our compass, our North Star, and we're digging our own graves by putting up all these high-rises left and right, not thinking of what we're doing. As the lady for the sewage said, we're at maximum capacity now, and we're trying to bring in like 30,000 more people without thinking of how many more hospitals do we need, how many more schools do we need, how many more parks. And if you look around Kakaako, there is no green space. There is no place, no parks, no recreation, no greenery, basically. And we're just trying to make it a concrete jungle. And I think it's up to us citizens to take a stand and bring attention to this issue that we don't want a concrete jungle here. We're the ones who have to live here, not these people who come and buy all these condos and leave it empty, basically. And we have to push for a more green environment and for a solution for this mess that we're in. Thank you.
I think that was a great wrap-up of ideas, and I'm going to pass the mic on. Yeah? Okay.
I would like to address this to the students. This is a thought that I've always had. The Hawaiians didn't have a numerical system of naming their property. And under the Mahele, and even before that, when they got property, if you see the word Y or Kai in the name, investigate. A lot of times it's water.
Does anybody have anything final that they would like to share before I pass the mic on to Karen?
Okay. It was great to hear that a junior in high school was here. Isn't that right? And I want to just give him a hand. It's your generation. It's my daughter's generation. It's some of your grandchildren's generation that's going to inherit this planet. And that's going to inherit everything that we're doing today, right? The buildings, maybe no buildings, whatever it is, canals or whatever where our imaginations take us. I think there's a lot of conflict and a lot of difference about what we should do. If you just bought a condo here, like one of my students who recently graduated, it's not good news to see this, right? Because this is an investment for his and his fiance's lifetime. For those who do business here, own property here, or developing here, and even those like Lori who have to manage all of these problems, it's a really daunting issue. And one of the things that we'd like to do just with this public academy, like I said, we're not here to to solve the problems, but we're here to educate ourselves, help educate each other so we could have reasoned, intelligent conversations about how we as a society collectively can address these problems. There are many alternatives, and there's not going to be complete consensus over which approach to take. But let's have the conversation. And I think what we need is for young people like you, sir. What was your name? Andrew, to help catalyze these conversations, but also those, some of us old farts too, right? It's going to affect us too. So I really want to applaud Judith, Danielle, Lori, for tackling these issues every single day and for inspiring the rest of us to feel that we can join the conversation as well. This is the purpose of the Public Academy. This is the spirit of collaboration and imagination that we want to promote. And we really thank all of you for participating today. And can we give the students a hand for preparing this? I'm going to let Annie say a few words about last week and next week.
So thank you to everyone who came last week and came back today. Just wanted to show you what a full house we had last Tuesday and another full house that we have today. One of the things that we asked folks to do is share with us their ideas of what is livability, what is a healthy kakaako. So we did a word cloud out of that. We'll be posting it on our website as well. The topic was livability, so what is a healthy neighborhood like? So just thinking about what would that mean to you, to your family. So we have a range of things. Oh, question in the back? Yes, so we're going to get back, we're going to email that out to all the participants and also share it at the next one. So one of the things that we realized, because the time is so cramped, is that we actually don't get to do everything in this 1-2-hour framework. So unfortunately for the questions that people have for Lori, we're going to give them to her and then relay the info back to you. Question? Oh, this is the Departments of Urban and Regional Planning's website. It should be on the materials. If not, we'll fix that immediately. But we'll also bring it to each workshop, right? And we'll email everyone whose email address we have the website.
So be sure to leave your email address.
Right. So, the green form that we gave to you as you came in, these are things that we would love to hear back from you. So if you learned something, share that. If you have questions, please ask them. If there's something that you feel inspired to do or something that you think you can do, please also share that with us. We've been compiling them. We'll also take everything into consideration. We want this to improve with your input. And the very last thing that we wanted to ask, so many things going on. Our fourth workshop is called Envisioning a Place for Everyone, and we were hoping to highlight photos of everyone in this room. So if you want to share a special place in Kakaako, if you want to share an old photo, a new photo, something from the shoreline, something from right around here, we would love for you to either email us that photo or just bring it, and then we'll take a picture of it at an upcoming workshop. And then our next workshop is affordable housing, and we're very excited about that. We have a great lineup, including some planners and students who will be walking us through some exercises, but also Marian Gushikin from EAH Housing, who is developing the micro-unit project in Kakaako, as well as other affordable housing projects. And then Harrison Rue from the City and County Department of Planning and Permitting, who will be talking about this kind of city's vision for affordable housing and how that might be in alignment with the vision for Kakaako and affordable housing.
And I'd like to also make one more announcement, which our department is having every year, we have a World Town Planning Day. It's our annual kind of public education big event. And the focus is on learning lessons from Katrina, which is very relevant to today. So this is November, and again, we could shoot you an email with the details, but November 12th, Thursday evening at 7 p.m. on campus in Crawford Auditorium. So any of you who are interested in lessons from Katrina and how they're applicable to Hawaii, please join us then. I think that's it for today. Feel free to mingle. We always try to start on time and end on time like a regular class. So thank you very, very much.